Hi, welcome everyone. So in this session of generative AI interview preparation part 3, we will be answering question number 3, and I'm going to explain this to candidates so that they have a better understanding how does memory management work in Python. So in the interviews, when this question is asked, how does memory management work in Python? That Python uses automatic memory management with reference counting and garbage collection. So these are the two important concepts, reference counting and garbage collection, to free objects, and it allocates memory dynamically to manage objects efficiently. So this was a very basic answer which I have given. And basically the ideal answer is something where we talk about Tracemalloc as well, which is a missing keyword which we should always use when talking about memory management. So basically, if you see, Python manages memory automatically. This is the first statement. So in C Python, what do we say? This mainly relies on the reference counting. Okay. So in Python, we can say this mainly relies on reference counting. This is the important concept which we have to learn in this, discussion. Then what we have is, and the answer says when an object's reference count drops to zero. Okay, so this is an important point. So when an object's reference count drops to zero, its memory can be released immediately. Okay, and what is the meaning of this statement? So I have an image for you to display and discuss about this particular part. So here, if you can see, so this image is a reference counting image, which I will be using. And now here you can see, we'll be discussing about how memory management works in Python. And as the answer says, Python manages, memory automatically. Now, the first concept is reference counting, which is the main mechanism. Okay. So now if you can see here that every object has a reference count, this count increases when an object is used and it decreases when that object is deleted or removed. Okay. So suppose we have created variable A, which is a list, and within that list, let's say I have added three elements, 1, 2, 3. Okay. Now this A becomes an object. Basically, the object becomes 1, 2, 3, and the reference count becomes 1. Okay. So this says that this is reference count 1. Now, suppose I create another variable B and I assign A to B. So in that case, now we have two references. Okay. For the same object, 1, 2, 3, we have two references. One first reference is A and second reference is B. Okay. So now reference counting says that now we have got two references for that object. Now, similarly, let's say I have deleted B. Okay. So the object is 1, 2, 3, and the reference count again becomes 1 because now A is referencing to this object 1, 2, 3. Okay. So now the answer says when reference count becomes 0, okay, becomes clear to everybody. So this is the meaning of this statement. When an object's reference count drops to 0, its memory can be released. Python also has a cyclic garbage collector, okay, to detect and clean up reference cycles that reference counting alone cannot handle. Okay. So whenever there is a cyclic object allocation, okay, there it is not easy for a reference counter to delete it, okay, or to free the memory. So in that finds out this cyclic differences, and then it frees up the memory space. And let's use the image in order to explain you the second concept. So now the second concept is this garbage collection, and this is basically used for cyclic object allocations. Okay, so suppose you have an object A which is referred, and so it refers to B, and then object B refers to A. Suppose this is the case. Okay, so what we can see here is, for example, so some objects refer to each other in a cycle. Okay, so there are certain objects which refers to each other, and in this we use Python's garbage collector, which detects such cycles and then cleans them up. Okay, so detects these unreachable cycle and frees up the memory. Okay, now, so what you can do is you can in fact write a basic code. Let's say I have imported garbage collector, so you can use GC to import garbage collection. Now you can create a class known as node, okay, where you have a initializer, and you're going to reference that initializer to self. Now we are going to create a cycle. So suppose you created a cycle known as A is equal to a node and B is equal to node. So both are these nodes. Now A is referencing to node B and node B is referencing to node A. Okay. Now, even after you delete node A and node B, now what you need is you need gc.collect function to free this cyclic space. Okay. And this is very important. It runs periodically in the background, and you can manually trigger it as well using gc.collect function. Okay. So now let's have an example. Let's have a In fact, we can use Thorny in order to have an understanding. Open Thorny. Thorny, we can use Thorny in order to explain this Python memory management part much better. Now let's say demo1.py. Okay. Now let's say I've created a list 1, 2, 3. Okay. So let's run it. So once I run, you can see that here we have got one object created at a memory location, and the object is 1, 2, 3. And here we have got one reference. Okay. So here is the reference A. Now, suppose I assign B to A. Okay. So I've assigned B to A, which is 1, 2, 3, which is at this memory location. But now we have two references. Okay. Reference A and reference B. Okay. So these are two references. And now let's say let's say delete A. If I delete A, okay, and if I run it, so now if you see, now you only have one reference left. Okay. This is your reference counter. Mechanism was reference counting for memory management in Python. And the second concept is garbage collection. Okay. Now what garbage collection is used? So garbage collection is used for cyclic. Say we're going to make a class. We're going to make a class node. Okay. And then we're going to define this function in it. Okay. And what we can do is, so let's say we can, take a self here. Let's say I'm going to initialize the self. Okay. So we are going to initialize this node, and let's which we created. Now what am I going to do? In fact, for garbage collections, we are going to import GC. Okay, GC is the garbage collector which we are going to use. Now what we need to do is, let's say we are going to create a circular reference, and now within this circular reference, what are we going to do? We're going to use a node. Okay, so A is a node and B is a node. I have created A will refer to B and B will refer to A. Okay, so now we have cyclic references. Okay, now what we can do is I can quickly delete main references. Okay, so let's say if I delete these references now, del, or what we can do is, let me just quickly show you how that. I have imported garbage collector. Okay, that is in memory. I have created a node. Let's say we'll do one thing. Let's just remove this reference counting part now, so that you can have a better understanding of that. We have these objects node for garbage collectors. Okay, so now we have a node created. Now we have a reference A, we have a reference B. Okay, we have referred A and B. Now let's say even if I'm going to remove these references, so I'm going to say let's say I'm going to delete the reference A. Okay, and I'm going to run it. So if I delete this reference A, now you can see we have only B left, GC left, and node left. And I'm going to delete a reference, let's say B. Okay, now when I delete this reference B, you can see that A has been removed and B has been removed. Okay, but still force garbage collection. And now I'm going to call this function gc.collect. And now when I'm going to run, okay, so now you can see that garbage collection would be done and memory optimization would be done. Okay, so basically in such cases, basically at the background garbage collectors run all the time, but in case if it doesn't run, you can use this function gc.collection. So I believe this is clear now, and you have got a clear understanding of how memory management works in Python. What is the reference counting and what is garbage collections? Okay. Now, now let's continue with the answer. Uh, let's just discuss the standard answer. Now here, if you see, so memory allocation for many small objects is optimized by Python's private allocator. Okay, and developers usually do not manually free memory, but they should avoid unnecessary object retention, circular references with finalizers, and large unused data structures. Okay, so there are certain tools like gc, Tracemalloc, and profiling libraries which can help investigate memory issues in real applications. Okay, so when you're writing scalable application, you need to ensure that your application is utilizing memory appropriately. Okay, now what we will do, so Python has a memory allocator. So Python uses private memory pools for smaller objects. It reuses memory for efficiency, and it has faster allocation for better performance. And there are certain good practices which we should use in order to avoid memory issues. So that is, don't keep unused data. If there is any unused data, kindly remove it from your program. Avoid creating unnecessary large lists or objects. Okay. Then be careful with circular references, especially with delete methods. Okay. Delete or clear large data structures when not needed. It is obviously a good idea to delete those connections. Generally, people avoid that. Beginners, those who write that code, they skip this part. So for good Python, what we have to do is then we have tools to monitor and debug these memories. Okay, so we can have we can use gc module in order to get the garbage. Okay, so let's quickly do that here. So I'm going to use gc dot, and this is get under. Okay, let's run it. So you're going to see currently, everything is freed up. That's, I'm not going to delete it. and let's run it. Okay, so currently this stays fine. Okay, we can basically use whenever there is any garbage, in collector. You can see that with count, and you can release those. Similarly, we have another tool which is known as Tracemalloc, which is to track memory usage, and we can use it. So now let's say we are going to implement this function. So what we are going to do, we are going to import Tracemalloc. We are going to use tracemalloc.start. Okay. Then we are going to write a code. Then we are going to get two information. When it was current, when it was peak, the memory utility. So we are going to call this function get traced memory, and it is going to give us the current memory states and the peak memory state. And then we are going to print that. Okay, so we are going to print the current memory stack and the peak memory stack. So let's do that in the code here. Okay, now so let's just get it going. So what am I going to do? I'm going to write it. Let me just write a new program. Let's call it as Tracemalloc. Okay, uh, here I'm using Tracemalloc. So I'm going to import my trace memory allocation function. Okay, this is a tool which tracks memory usage. Okay, now what we are going to do, I'm going to write a function. Let's say tracemalloc.start. With this, you can start monitoring, utility of memory, and then we can have our piece of code. Okay, so for now here I'm just making, let's say I'm going to make a very large list. Let's say I'm going to make a large list. Okay, and for this large list, what I'm going to do, I'm going to make a loop for I in, let's say, range. Okay, where I can use a value like, let's say, 1 lakh. Okay, so I'm going to create 1 lakh objects. So I'm making a loop where I'm going to, put these values from 1 to 1 lakh in I, and then I'm going to store that in I. Okay, and this is an example of a list comprehension which I'm implementing. So now in this list comprehension, now I'm going to run this value of I, and I'm going to put it in I, and a list of 1 to 1 lakh would be made. Okay, and I have stored that, let's say, into an object A. Okay, then what we are going to do, going to get the traced we are going to get the traced memory. Okay, so we are going to use tracemalloc, and we are going to get the traced memory. Okay, so get traced memory, if that we are going to quickly see. We're going to get the traced memory, and this is going to respond me the current memory state and the peak memory state. Okay, that is what it is going to. What we're going to do, we are going to print. So first I'm going to have my, let's say, current memory. Okay, that I'm going to print, and let's say I'm going to drop it like current, plot it in terms of, just put that in brackets. I'm going to print this value, and I'm going to define it as MB megabytes. Okay, so let's just remove it. Let's say current, and let's just use F. Okay, so this is going to be, I'm going to use the current memory. I'm going to use current. I'm going to convert that into MBs. Okay, and similarly, we are going to have the peak. Okay, let's say this is going to be the peak memory. For peak, I'm going to calculate peak. I'm going to calculate peak, and I'm going to again convert that into MB. That's how we are going to print this. And finally, we are going to trace malloc dot stop. I'm going to stop this. Okay. So now, okay, so here it says, okay, that sorry, in the library module, consider remaining or moving it. Okay, so it's using tracemalloc dot UI. Okay, mistakenly I had just made this code with the wrong name. So let's just change it to tracemalloc. Okay, let's call it here, and now we are going to run it. Okay, so now you can see, now when we run, we can see that we have got this output 3.5 MB, 3.5 MB, and that is what it is displaying, that what is the current memory allocated for this particular code. So now you can see that in order to make a list of around 1 lakh items, around 3.5 MB of space would be utilized. Okay. I believe this is clear. So that is how memory management in Python is practically done. I believe now you have a fair idea. So now, if anybody asks you how does memory management work in Python, you can specifically say that Python manages memory automatically. In Python, it mainly relies on two functions. It mainly relies on reference counting. So when an object's reference count drops to 0, the memory is released immediately. Also, Python has a cyclic garbage collector to detect and clean up reference cycles that the reference counting alone cannot handle. And memory allocation for many small objects is optimized by Python's private allocator. Developers usually do not manually free memory, but they should avoid unnecessary object retention, circular references with finalizers, and large unused data structures. And profiling libraries also, which can help investigate memory issues in real applications. Thank you so much for watching.